Okay, let me see if you have forgotten how to do quadratic equations. Maybe I can catch you this morning. I'll try one. Says fox times fox minus 5 times fox plus 6 equals 0. Anybody think they know? Two numbers, anybody think they know? Barbara.
Well, one's 2.
Barbara says one number is 2. Is that right, anybody?
Yeah.
Is that right?
Yeah.
2. I'll write that. And what's the other number, Laurie?
3.
3. Is that right?
Yeah.
So you do remember how to do those. Try another one. Fox times fox minus something or other times fox plus something or other equals 0. And I'll think about this for a minute, I guess. Oh, I know. Fox times fox minus 15 times fox plus 26 equals 0. And I hope I did that right, or else it won't work. Maybe I did. Give up?
No. Wait.
Don't give up. Who thinks they know?
I'm not sure.
Who wants to try and be on a team of experts? Okay, Laurie, Kate, Peggy, Ruth, Ann. 2, 2, 3. If you do, you're the team of experts. You agree? Okay, they're the team of experts. Why don't you?
Back here. I'll tell you why.
They changed their mind.
That path won't work.
Maybe they can't do it. Maybe I better check up and make sure I can do it. I think I can do it. Who else thinks they know? You? Oh, Avery. Okay, stay right here. You're the team of experts. Okay. You could talk. Anybody? Bob.
1.
Bob says 1.
Nope. No.
Nobody else wants to guess. Who else? Frank.
2. Yeah. That's 13? Uh-huh.
Okay, thank you. I guess I'm never going to catch you with that kind. I'll try something else. This is going to say, do you want to be the team of experts for the next problem? You don't know what it is, but you'll be the team of experts anyhow. Okay, it says positive 10 plus the number in the box equals positive 12. What do you suppose the true set to that one is? Well, you can't guess. You're the expert. You people can guess. Mary Ann.
Positive 2?
Expert.
Yeah.
They say that's right. You want to be the expert for the next problem? All right. Positive 10 plus fox equals positive 10. Bob says 0. Experts, is that right? Okay. I'm going to have another one in a second. 0. Another one. Positive 10 plus fox equals positive 3. If you want to talk, I'll give you a mic. Want a microphone? Okay. Take the mic if you want it. Laurie has a speech. Oops.
Well, I don't think it could be positive then if it would equal 3.
Laurie says the number can't be positive.
Yeah.
Is that right?
Hey, what's your line?
Who's guessing? Bruce.
Negative 7?
Negative 7. Experts, is that right?
Yeah.
Is that right?
Right.
You think it's right?
But it can't be that way. Can't have it not
You don't think negative 7 will work? I think negative 7 will work.
Not form.
Bet you can. Positive 10 plus negative 7 equals positive 3.
Yeah. negative?
Yeah, positive 10 plus negative 7 is positive.
I see negative 7.
Okay, another one says positive 10 plus box equals 0. How about this? Positive 10 plus box equals 0. Let's see. Bob, that's off.
Negative 10.
Negative 10, is that right, expert?
Yeah, that's right.
That's right. You're sure?
Okay,
We're positive that it's negative 10. Okay, I'll try one more of these and then I give up on those. Positive 10 plus box equals negative 4. And now there's one that even the experts can't do. Give up? Right?
Negative 14.
Is that right? That's what he says. That's what they say. I guess it's probably right. Negative 14. So now I do give up. I want to do something else. Put this sound system back together if I can, and we'll do something else. Okay.
I want to hear another.
You want to give another speech? Wait a while. I'll ask you a question later, and then you can give a speech. Okay. Why don't you sit down so you can do the next thing, and I'll show you the next thing I want to do. What I'd like to do this time is see if any of you can make up an open sentence that'll be true no matter what number I put in the box. Open sentence that'll be true no matter what number I put in the box. Can you do it? Any takers? Kate. Laurie.
Is there only one box?
Up to you. You're doing it. The rule for substituting works. You can have several boxes, and then the rule for substituting works. If you want something else, you use triangles or something like that. Anybody got one? An open sentence, it'll be true no matter what number I put in the box. Laurie.
Well, anything, if you have two boxes, it could equal up to 10. Anything you put in there, well, no, not anything. Anything would equal 10.
But that won't do it. Let me try one and see if you think it'll work. Suppose I write 3 plus box equals 7. Will that be true no matter what number I put in the box?
No.
Ruth says no. And that's certainly right, isn't it? For example, if I put a 3 in the box, it wouldn't be true.
No.
Can you make up one that will be true no matter what number I put in the box? Peggy.
No, it didn't work.
Doesn't work. Bob.
Well, if you put 0 in the box, it will always be the same number that you had in front. Like if you had 3 and 0, it always has to be 3.
But now can you make that into an open sentence? That's a clever idea. He says 3 plus 0 would always have to be 3, and I agree with that. But you've got to do better, because that's not an open sentence.
You said it had to equal 7.
No.
You had 7 there for your first example.
No, but my example didn't work. I want you to make an example that does work. Good.
0 plus a number always equals the number?
0 plus a certain number always equals a certain number, and how can I write that as an open sentence? How will I write it? He says 0 plus a number always equals that same number. Sue, how can I write it?
0 plus box
Bob?
equals box.
All right. How about it? Will that be true, whatever number I put in the box? Remember, I have to observe the rule. It's known as Nancy's rule for substituting, is that right? I have to observe Nancy's rule for substituting. I have to put the same number in both boxes. And will that always be true? Okay, now an open sentence like this that's always true, we're going to call an identity. And now let me see who made this up. See, Sue and Bob and somebody else helped make this up. Who made this up?
Me.
Bruce. So this is known as the Bruce, Sue, Bob identity. Known as the Bruce, Sue, Bob identity. Do you think there are any others? Can you make up any other open sentences that'll be true no matter what number I put in the box? Or is that the only one?
No, we can get it backwards.
Peggy, try it.
The box plus 0.
Box plus 0. Where do I go from there?
Equals box.
Equals box, and that is known as Peggy's identity. Do you think there are any others? Bob.
Was it the box equals 0?
Say it again.
Box plus box equals 0.
Box plus box equals 0, and that's Bob, known as Bob's identity.
0, 0.
How about it? Is that right?
No.
Is that right? Kate?
No, because if you wanted to make it right, you still have to have different signs. And one would have to be a negative sign, and one would have to be a positive sign.
Kate says if that's going to work like that, you couldn't use the same number. Suppose I tried it out with something like a 7, and I put a 7 plus a 7 there. That's true. 7 plus 7 equals 0.
No.
Could you fix it up so that it would work? So I guess Bob's identity has sort of just gotten itself erased. I'll leave it there. I'll leave it there so you can fix it. It says box plus box equals 0. Can you fix it so it'll work? Other Bob.
0 plus 0 equals 0.
Except that that's not an open sentence because it doesn't have any boxes in it. So I can't put numbers in it. Laurie.
Well, it could work, but you would have to have certain numbers, and you couldn't do that with any number.
What's this? Box plus box equals 0.
Yes, you could, because, well, 7 plus 3, for example, doesn't work, and...
Well, but now I can't do that because I can't violate Nancy's rule for substituting. Whatever number I put in this box, I have to put the same number in this box.
It won't work indefinitely, anyway.
I think that's right, but can you fix it so it will work?
Yes, if you have negative and positive signs, like a negative 20 and a plus 20.
All right, let me show you a notation people use when if I have a positive 20 and you want to tell me change that to a negative 20, people use this notation outside of the box. They put a little circle up high like that, so it says when I put positive 20 in the box and use a little circle on it, that would be what?
Negative 20.
Negative 20. And suppose I have a box with a little circle on it like this and I put negative 20 into it. What would that be? Okay.
Positive 20.
You're right. That's exactly what it would be. All right, so there's one way to fix up Bob's identity so it will work. This is a version of it that doesn't work here. Somebody's going to fix it up so it does work by using that little 0. Bob?
But those aren't the same numbers. There's a difference between minus 20 and positive 20.
Oh, I quite agree. So you don't really want it. This is wrong. I wrote box plus box equals 0. That's wrong. It won't work. I want you to change it so it will. Can you do that? Well, I thought somebody was going to change it using that little 0, but don't do it that way if you want. Okay, can you change it using a little 0? I'll try writing it if you want.
You could put minus.
All right, we have to put the same thing in both boxes. Now, how about that? That's an awfully clever idea. What did she do there? She says instead of this, she's going to write, doesn't really have to have negative 20 in it to make it work. I think it might work with anything. Let's see. She's going to write box, plus, and then what did she write? Can you read that?
Yeah.
What is it? It's this little circle. The opposite. People call that the opposite. Box plus the opposite of box equals 0. Okay? And now suppose you put negative 20 in. Does it work? This is negative 20, and then the opposite of negative 20 will be positive 20. So it says negative 20 plus positive 20 equals 0. Is that true? So it works. So that's known as Kate's identity. Okay. That's one way to fix up Bob so it works. Can you fix up Bob so it works some other way? Don't use that little 0 for oppositing. Use something else. Can you think of another way to fix that up so it'll work? Laurie?
If you change the box plus box into a box minus box.
All right, that's a clever way to do it. Box minus box equals 0, so that's known as Laurie's identity.
It won't work all the time, but it will work with the same two numbers.
Oh, but that's what you have to do. Whatever number you put in this box, you have to put the same number in this box. That's Nancy's rule.
Mm-hmm.
And here, whatever number you put in this box, you put the same number in this box, but then you have to remember there's a little circle here that says, after you put it in the box, opposite it. Can you do that? I think you can change that still another way. Bob's identity turns out to be a great idea. It just doesn't work. If you fix it up, it's a great idea. Can you change it another way so it'll say box plus box equals something and work? Don't do anything to the left-hand side, but change the right-hand side this time. So it'll work. Barbara.
Box plus box equals box.
How about that? Box plus box equals box. How about it?
No, that's wrong.
Bob says that won't work. Who's right? Kate.
Bob, because 3 plus 3 isn't 3.
How about that?
2 plus 2 isn't 2.
Ooh, you're the expert. Who's right?
Kate's right.
Kate's right.
Okay.
That's what I think too. You and I and Kate agree that must be right. So that doesn't do it. Can you fix up Bob's version of Bob's identity so that it will work?
Box minus box is box.
Box. Well, I don't want you to change the left-hand side this time. I want you to change the right-hand side. Leave the left-hand side just box plus box equals, and do something to the right-hand side so it'll work. Could you do that? Any takers? Has anybody else got any other identities, huh? Thought of any other identities at all? All right, I want to ask you one more. Suppose I started this. It says box plus box plus box equals, and could you make a right-hand side on that so that it'll work? And be an identity. Bob.
Equals 3 boxes?
Box plus box plus box equals, what would you like me to write here?
3 boxes.
All right, 3 times box. How about that? Is that an identity?
Yes.
Is that right? It really is? If I put 7 in, it'll work? 7 plus 7 plus 7 equals 3 times 7? Is that true? Okay. So that's what it must be. Now that's Bob's identity, is that right? Good, that's known as Bob's identity. How about this other one up here, the other Bob's identity we're trying to fix up? Box plus box equals box. Can you fix that up so that'll be an identity?
2 boxes.
Tell me exactly what you want me to write. Box plus box equals.
2 times box.
2 times box. 2 times box, that's known as the Ruth Bob identity. We've probably got as much advantage out of this as we can, so we're going to erase it now, okay? We fixed it up quite a few ways. So that didn't work, but if you change it, it does. You can say box minus box equals 0, or you can say box plus the opposite of the number in the box equals 0, or you can say box plus box equals 2 times box, and that's an identity. Do you know any others? Yeah.
Box times 0 equals 0.
Box times 0 equals 0. Box times 0 equals 0, known as Marianne's identity. You know any others? Bruce.
1 times box equals box.
1 times box equals box. Known as Bruce's identity. Ah.
0 times box equals box.
0 times box
equals 0.
Excuse me? Didn't hear you.
I said 0 times box equals 0.
0 times box equals 0. And now we're getting the Bobs mixed up. You're Bob sub 1 and you're Bob sub 2. Which Bob was it who did this?
Sub 2.
Sub 2. And this is Bob sub 2. And this is Bob sub 2. And this is going to be Bob sub 1 here. Is that right? Bob sub 1's identity. Okay. No any others? Bob sub 2.
What if you have 1 times 0? By Bruce's identity.
This is in, let me see, which one are we looking at? In Bruce's identity? How much is 1 times 0? Does anybody know?
Oh, yeah.
That's right. So it works. Do you know any others? I suppose that's all there are. Want to bet me that I can't make up any more?
You could, with that box plus box equals 2 times box, box times box, box plus box equals 2 times box, box plus box plus box equals 3 times box. You could go on and on with that, and, never end.
That's right, Okay, so now these are known as Ruth's identities, and I'm not going to write all of them. Fox plus Fox plus Fox equals 4 times Fox, I guess. Is that right? And the next one says Fox plus Fox plus Fox plus Fox, 1, 2, 3, 4, 5 equals 5 times Fox. And do you know how mathematicians show that it could go on like this forever and never ends? Laurie?
Put 3 dots.
Yes, you do know. That's what I'll do, 3 dots. And these are all known as Ruth's identities here. Those are all known as Ruth's identities. There are a lot of those. Okay.
The word for going on and on forever is infinite.
I guess that's probably right. Actually, I like the way she said it even better, to tell the truth. Anyhow, it does go on and on forever like that, doesn't it? We put down 3 dots, and that's what that says. And as you say, all right, this is Ruth's infinitely many identities or something. Do you know any others? And Dr. Wirmore. Others.
Well, the 1 times Fox equals Fox. You could go on forever doing that, too.
Okay, tell me how.
Well, it'd be like 2 times Fox equals Fox.
2 times Fox equals Fox. And what'll I do next?
3 times Fox equals Fox.
3 times Fox equals Fox. And these are all known as Barbara's identities. Is that right? How about that? True.
That doesn't work. Because if you use 2 times 7 equals 7, 2 times 7 does not equal 7. If you put 7 in the box.
How about that?
So it only works if you put 0 in the box.
I bet that's probably right. Only works if you put 0 in the box. So what'll I do with Barbara's identity? Erase them, I guess. Any others? Marianne.
Can we reverse Ruth's identities up there and say 5 times Fox equals Fox?
Okay. Here are lots more. Here are another infinity of identities. Marianne's identity. And they all say 2 times Fox equals Fox plus Fox. And is that what you want me to do? Yeah. And 3 times Fox equals Fox plus Fox plus Fox. And then what will I say next? To show that it goes on like that forever. Marianne?
3 dots.
3 dots. 3 dots. Can you get any more, do you think? I suppose that's all there are. Now are you ready to bet me that I can't find any more?
No. I think all of them on the board are reversible.
Oh, my word.
No.
Okay, well, now those are known as Kate's reverse identities down here. And she says whenever I have something, that's a squiggle for something, equal to something else that's an identity. This is another kind of squiggle here. Kate says what I can always do is reverse it. So whenever I have that, I can say this kind of squiggle equals this kind of squiggle. And those are known as Kate's reverse identities, I guess. There are lots of those. Laurie.
And really, with some of them that are infinite, like Ruth, you could go on and on forever, so we couldn't bet you that you could never find any more.
I guess you have a point there, but if I just find one that's like hers, then you can say, well, that's already there. If I just say box plus box plus box plus box plus box plus box plus box plus, I think that's where I should stop, equals 7 times box. If I did that right. You say, oh, but that's really on the list because that's really one of Ruth's.
You mean like we should just say that Ruths have already been counted, pretend we've counted all of Ruths, and see if there are any more that we can find?
I guess that's right. That's right. We'll pretend we've counted all of Ruth's and see if we can find any more.
Mm-hmm.
And I don't think I want to find any more identities today. That's enough identities. Have you got enough energy to do something else? You have. Okay. Let me see how much time we've got.
Let's play the game. Let's play the game.
Well, we might do that, but I want to do one other thing first.
Did you go, Paul?
I don't have to worry about erasing the board. You see, these are all permanent now. We have them on the videotape. We know. fact, one of these days, if I can, I'll send you a dittoed list of these so you'll have a record of them if you want. All right, and I'll tell you what I'd like to do. I want to try... Got to find something you can't do. I want to try something different. Maybe you can't do. This says triangle equals 1 times box plus 3. And now, that's an open sentence. Is it an identity? Bob?
No.
Bob says no, it's not. Anybody prove that he's right? Or that he's not right? Or something? Peggy?
Because you have the equal before you have the rest of the problem?
Doesn't convince me. Bob, can you prove it?
Well, in that case, that triangle, I mean, it must have infinite answers because you can say 1 times 1, 1 times 2, 1 times 3, 1 times 4, and each time you get a different answer.
Well, to prove it's not an identity, what would you have to do? Somebody want to say again, what is an identity? It's an open sentence that does something peculiar. What is it that does? Bob?
That proves that whatever comes in the box, it always works.
Yeah, it's always true, isn't it? It's an open sentence that's always true. So if you wanted to prove that this is not an identity, what would you do? Laurie, what would you do?
Well, you could change the 1 to something else, and you wouldn't get 3. You'd get some other answer.
Oh, but I don't want you to change it. I want you to see whether this is an identity or not.
Well?
Now, if it's an identity, no matter what numbers I substitute in the box and triangle, it must come out to be true. Laurie?
Well, if you can put numbers in the box, so the answers wouldn't be 3 plus 3 all the time.
Well, what do you have me put in the box?
Well, anything like 7 and...
All right, 7. What'll I put in the triangle?
6.
6. All right. And she says no, she can prove that Bob sub 2 is right. It says 6 equals 1 times 7 plus 3. And Laurie says now she can prove Bob sub 2 is right, and Bob sub 2, can she?
Well, I don't know. Except what if that triangle means numbers, then what?
Well, the triangle means put some number there, and I did it. So it says 6 equals 1 times 7 plus 3.
Oh.
Is that true?
No. Yeah, no.
True. Is it true? Yes.
No.
So how about that open sentence? Triangle equals 1 times box plus 3. Is it an identity or not an identity? Kate.
It's not an identity.
Kate says it's not an identity. What do you think?
It isn't.
No.
No.
Because if it were an identity, it has to be true, I guess. Okay, well, I agree it's not.
No.
But it's true if you put the right pairs of numbers in, I'm saying. And I want you to tell me some of the right pairs. It's going to have a box and a triangle. And let's see. Can somebody tell me a pair of numbers? Oh, this works the same way that it does when we're playing the point set game. The first number you tell me goes in the... Remember? First number you tell me goes in the box. The second number you tell me goes in the triangle. Okay? So tell me a pair of numbers that will make it true. Marianne?
10 and 7.
10 and 7. 10 in the box and 7 in the triangle. How about that? 7 equals 1 times 10 plus 3.
No, I mean 10 in the first one.
Okay, but the number you tell me first, I put in the box, right?
Oh, okay, then 7 and
Rule.
10.
10, 7 doesn't work, but as Marianne says, 7, 10 works. And is that really true? Is that really true?
No.
Take a vote. Who says it is true? And who says it's not true? Okay. Anybody convince anybody? Okay. Convince anybody?
Well, because if you can, 10 doesn't equal 1.
So if I put a 10 in the triangle and 7 in the box, it says 10 equals 1 times 7 plus 3, and that's not true. That's true?
I think it's right. I think it's true.
You think it's true?
I can convince it too.
You convince her? Okay.
Because there's a 10 in the triangle, and 1 times 7 is 7, and 3 is 10, and
So what this
so
really
10
says is
equals that,
10
and so
equals
it is.
7 plus 3. Are you convinced?
Mm-hmm.
You did convince me. Can you tell me another pair of numbers that will work? Frank.
3 and 6.
3 and 6. 3 in the box, 6 in the triangle. Is he right? Let's do something else. Have you got enough energy to do something else? You have. Okay. Let me see how much time we've got.
Let's play the game. Play the game.
Well, we might do that, but I want to do one other thing first.
Did you go, pause?
I don't have to worry about erasing the board. You see, these are all permanent now. We have them on the videotape. No, we know. In fact, one of these days, if I can, I'll send you a dittoed list of these, so you'll have a record of them if you want. All right, and I'll tell you what I'd like to do. I want to try... I've got to find something you can't do. I want to try something different. Maybe you can't do. This says triangle equals 1 times box plus 3. And now, that's an open sentence. Is it an identity? Bob.
No.
Bob says no, it's not. Anybody prove that he's right? Or that he's not right? Or something? Peggy.
Because you have the equal before you have the rest of the problem?
Doesn't convince me. Bob, can you prove it?
Well, in that case, that triangle, I mean, it must have infinite answers, because you can say 1 times 1, 1 times 2, 1 times 3, 1 times 4, and each time you get a different answer.
Well, to prove it's not an identity, what would you have to do? Somebody want to say again, what is an identity? It's an open sentence that does something peculiar. What is it that does? Bob.
That proves that whatever comes in the box, it always works.
Yeah, it's always true, isn't it? It's an open sentence that's always true. So if you wanted to prove that this is not an identity, what would you do? Sorry, what would you do?
Well, you could change the 1 to something else, and you wouldn't get 3, you'd get some other answer.
Oh, but I don't want you to change it. I want you to see what this is. It is.
Well.
Now, if it's an identity, no matter what numbers I substitute in the box and triangle, it must come out to be true. Sorry?
Well, you can put numbers in the box, so the answers wouldn't be 3 plus 3 all the time.
Well, what do you have me put in the box?
Well, anything like 7 or...
All right, 7. What do I put in the triangle?
6.
6. All right. And she says now she can prove that Bob sub 2 is right. It says 6 equals 1 times 7 plus 3. And Laurie says now she can prove Bob sub 2 is right, and Bob sub 2, can she?
Well, I don't know. Except what if that triangle means number? Then what?
Well, the triangle means put some number there, and I did it. So it says 6 equals 1 times 7 plus 3.
Oh.
Is that true?
No.
True. Is it true? You're the expert.
No.
So how about that open sentence? Triangle equals 1 times box plus 3. Is it an identity or not an identity? Kate.
It's not an identity.
Kate says it's not an identity. What do you think?
It isn't.
Not.
Not.
Because if it were an identity, it has to be true, I guess. Okay, well, I agree it's not. But it's true if you put the right pairs of numbers in, you're playing. And I want you to tell me some of the right pairs. It's going to have a box and a triangle. And let's see. Can somebody tell me a pair of numbers? Oh, this works the same way that it does when we're playing the point set game. The first number you tell me goes in the... Remember? First number you tell me goes in the box. The second number you tell me goes in the triangle. Okay? So tell me a pair of numbers that will make it true. Here again.
10 and 7.
10 and 7. 10 in the box and 7 in the triangle. How about that? 7 equals 1 times 10 plus 3.
No, I mean, 10 in the first one.
Okay, but the number you tell me first I put in the box, right?
Oh, okay, then 7 and
Rule.
10.
10, 7 doesn't work, but as Marianne says, 7, 10 works. And is that really true? Is that really true?
No.
Take a vote. Who says it is true? And who says it's not true? Okay. Anybody convince anybody? Okay. Convince anybody?
Well, because if you can, 10 doesn't equal 1.
So if I put a 10 in the triangle and 7 in the box, it says 10 equals 1 times 7 plus 3, and that's not true. That's true?
I think it's right. I think it's 2.
You think it's 2?
I can convince it too.
You convince her? Okay.
Because there's a 10 in the triangle, and 1 times 7 is 7, and 3 is 10, and
So what this
so
really
10
says is
equals that,
10
and so
equals
it is.
7 plus 3. You convinced?
Mm-hmm.
You did convince me. Can you tell me another pair of numbers that will work? Frank.
3 and 6.
3 and 6. 3 in the box, 6 in the triangle. Is he right? Susan, is he right? Susan says yes. Marianne, is he right?
Yes.
Okay, tell me, suppose I put 1 in the box. What could you put in the triangle to make it true? Okay? 2. 2. Bob's up 2.
4.
Now, you're telling me 2 works or 4 works, or suppose they both work, or what?
No. You can just put in the number 4.
Does 2 work?
No.
2 doesn't work. I put 2 in the triangle and 1 in the box. It says 2 equals 1 times 1 plus 3. Does it work? Marianne.
No. Because 1 times 1 is 1 plus 3 is 4. And
So you agree with Bob sub 2 that instead of putting a 2 in the triangle, I should
4.
put a 4. That's easily done. Okay. Suppose I put a 2 in the box. What should I put in the triangle? I'm ignoring Bob sub 2 because the rules say he can't do it all. Bruce.
5?
5. How about it? Is that right? Is that right? And we already know what happens if I put a 3. Suppose I put a 4 in the box. What should I put in the triangle to make it true? Okay? 7. Is that right? 4 in the box, 7 in the triangle. Is that right? Okay. Now I want to try and represent this. This is really a table here for the truth set. This is really a table for the truth set for that open sentence there. Now I want to try a graph.
A lot bigger.
Okay, I'll stop there and I'll make it bigger later on if you want me to. This is an expandable graph, not like the one 2.6. We make it bigger if we want. And this is going to be a graph for the truth set. Now, could somebody come and find this point 1, 4 and mark it on the graph? Piggy, you want to come try that?
Yes.
Okay. Remember, we count from the heavy lines, and we count the box numbers, the way that arrow shows, and so on. I think that you didn't quite count right. 1. Now you want 1, 2, 3, 4. I think that's about it right there. Good. Make a circle if you want. Okay. Peggy's marked a circle there, and do you think that's the right place for 1, 4? Pick up. It's 1, 1, 2, 3, 4. I guess it is. I'm going to fill that in if that's all right. Circle right there.
We don't like the big dots up there.
What?
We don't like the big dots up there. Solid circle. We want one
As a matter of fact, I'm going to make these smaller circles, I think, because this is a smaller graph this time. Smaller circle, I think. Somebody come and mark 2, 5. Ann. Oh, Kate. Well, I'll tell you, Ann, why don't you come and mark 1, and then Kate, if you want to come, I'll get you another piece of chalk, and you mark 3, 6. But it doesn't quite work. Try again. We need a technical advisor. Who wants to come and be technical advisor? Ruth, you want to come to technical advisor?
Computing with 2 5 and 8 and 6.
I think that's right. No, I think that Kate has this in the right place. I think Anne's going to put his in the right place, too. Okay, somebody want to come? I'm going to fix up those lines a little. Okay, thank you. That's good. My staff got a little bit of race while everybody's working on it. Can you see those points? I'm going to mark them a little bit heavier. Make sure you can see them. Oh, now I know what I want you to do. Pretend that you don't know any arithmetic and you don't know any algebra, but all you know is geometry. I want you just to look at this picture here. Just look at this picture here and guess where the next point should be for this truth set. Okay, and then after you've guessed and marked it, then we'll come through there and see if you're right. Okay. Say that it's true, you're right. Pops up two, who's right?
Well, it should be right. It goes up
Okay,
diagonally.
come, Mark. Okay, I'm going to make that a little bigger. Okay. Come on. Bob says two says it should be there. Do you think he's right?
No.
Take a vote. How many people think he is right? And who thinks he's not right? We'll try and see, all right? Let's see. What is the point that he marked? Well, I'll count it, I guess. I'm near it. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. 4 and 7. 4 and 7. Does it work?
Yeah.
Is he right? There he is. Okay. Pretend you can't do any arithmetic, any algebra, but you just do geometry, and come and look at this and mark another point. And then I'll do the arithmetic afterwards. Nancy, I'm sorry. How about it? He's right. He's good. I'll count and see. Let's see. That's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 5, 8. 5, 8. How about it? He's right. One more of these, and I'll do something else. This is starting to get too easy, isn't it? Yeah. You want to try? Okay, how about it? Do you think she's right? I'll check just to make absolutely sure. I think you're probably right. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. 6 and 9. And is she right?
Yeah.
Sure is. Okay. New problem. I'm going to use crosses now. We're going to try another equation, and this time we use crosses instead of circles, so we can tell them apart. And this equation is going to say triangle equals 2 times box plus 3. And let's see, box and triangle. I'll start a table. Suppose I put 1 in the box. What would I have to put in the triangle to make it true?
5.
5. 1 in the box and 5 in the triangle. I bet that's right. Okay. Somebody want to come and mark that 1, 5 and use a cross this time instead of a dot so we can tell it apart? Peggy? How about it? Did you put it in the right place, do you think? All right? Is that really right? That's the expert, Luke. You got that?
1, 2, 3, 4, 5.
That's right. He says it must be, I guess. Okay. Forget that you know how to do arithmetic and algebra. And just look at the picture and use geometry and guess where you think the next point should be. Who wants to do it? Peggy. Thank you. How about it? You think she's right?
Mm-hmm.
Look at vote. How many people think she's right? And who thinks she's not right? Peggy, what do you think?
All right.
We think it's right. Okay, we'll check up and see. Let's see. It's 1, 2, 1, 2, 3, 4, 5, 6. 2 and 6. 2 in the box and 6 in the triangle. 6 equals 2 and 2, 4, plus 3. You right? She's not right. Maybe told me she was right. Is it right?
No. Yeah. No.
Sorry, is it right? I'll try and see. 1, 2, 1, 2, 3, 4, 5, 6. 2 and 6. 6 equals 2 times 2 plus 3. Is it right?
Oh, no.
Peggy.
No.
You want to move it? Okay, I'll take that point away. Who says I have to change that one? We're going to try another place. You're doing it.
Cheater.
Thank you. How about that? Is that right? Is that right? Bob sub 2.
No.
Bob sub 2 says no. I'll try it and see. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. 2, 9. Let's try it. 2 there, 9 here. Says 9 equals 4 plus 3.
No.
Is that right? Still not right? Still not right. That point has to go. Who's going to guess where it ought to be? Kate. Thank you. How about it? Is it right?
Yeah.
Everybody says that's right. Ruth, is it right?
Yes.
Ruth says it's right. So I'll check it anyhow, I guess, just to be absolutely sure. 1, 2. 1, 2, 3, 4, 5, 6, 7. 2 and 7. How about that? Right. Okay, now you're going to pretend that you can't do arithmetic, you can't do algebra, and you're going to just look at the picture and guess from the geometry where you think the next point should be. You're going to come do it. Laurie. Right. Right, thank you. How about it? Is she right? Kate, is she right? Bob sub 2, is she right?
No.
Ruth, is she right?
No. Then you must be wrong.
They say if they agree, you must be wrong. I'll check up and see anyhow. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9. 5 and 5. That's 5 and 9. Let's see. 2 times 5 is 10, so that says 9 equals 10 plus 3. True or false? Wrong. Okay, so that point has to go. I better straighten out a few of these lines. They're getting sort of murky. Just like that. Okay. Marianne. You're going to forget how to do arithmetic and algebra and just look at the geometry and guess. Thank you. How about it? Do you think she forgot about arithmetic and algebra and just did geometry? Lots of
No.
I'm suspicious. Do you think it's in the right place?
Yeah.
Who says it's in the right place? So I'll know. Kate says it's in the right place. Ruth says it's in the right place. Ann says it's in the right place. And Mary Ann and Joan, Barbara, Peggy and Sue, Nancy. I guess it must be in the right place. Somebody this time is really going to forget that they know how to do algebra and arithmetic, and they're really going to come and do it just by looking at the pattern here. Okay. Okay. Thank you. You want to take a good look at it and make sure you got it where you want it, Kate? That's right. Is it right?
No.
Laurie?
No, I don't think so.
Says no? Marianne?
No.
Nancy?
No.
Peggy? What do you think? Either. Okay, Kate doesn't like it either. She wants to put it somewhere else. I'll erase it if I may, and you'll put it somewhere else. Okay? I'll erase that. Think it's right this time?
Yeah.
Kate said she didn't get it right this time. Anybody else? What do you think? Marianne?
I think it's right.
The other Kate? You think it's right? Nancy?
I think it's right.
You think it's right?
I think it's right.
Even Ruth thinks it's right. Okay, somebody don't do any arithmetic. Want me to check it, or do you all believe it?
We believe it. I believe it.
Okay. Check it? Betsy says check it. Let's check it. Here. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 4 and 11. 4 in the box. And 11 here. And so that says 11 equals, so it's 8 plus 3. That's right. Someone says it's right. Okay. Somebody come mark another point. Don't do arithmetic. Don't do algebra. Just look at the pattern and guess. Okay. All right. Okay. Kate said I have to make a little more graph up here. She ran out of graph. Is it right? Marianne?
Yes.
I guess that turns out to be too easy for you too, doesn't it? I'm going to try one more. New problem. This says triangle equals 3 times the number in the box plus 3. And I'll get 1 point on it. And let's see. Suppose I put 1 in the box. What would I have to put in the triangle to make it true? 6. Is that right? 1 in the box, 6 in the triangle works. And I'll mark that, I guess, 1. 1, 2, 3, 4, 5, 6. And now I'll use a circle. Wait, Peggy wanted me to in the first place, I guess. A circle. Somebody come and guess where another circle should be to make it true. Sorry? Okay, thank you. How about it? Yeah, right. And I'll check it and see. Right here. 1, 2. 1, 2, 3, 4, 5, 6, 7, 8, 2, 8. 2 and 8. Says 8 equals, take them to 6 plus 3. Right.
I think it's wrong.
That's because it's not right.
It's wrong. It's wrong.
Laurie says it's not right. Barbara, what do you think?
Wrong.
I'll take it away, I guess. Huh? Erase that one. Didn't work. Now, the rule is you've got to guess. You can't do the arithmetic, you can't do the algebra, you've got to guess. Come and guess where the next point's going to be. You've got to really and truly guess. Barbara, come guess it. Okay, thank you. Barbara guesses that the next one goes there, and what do you think? Do you think she's right? I think she really did guess, so I think she was not doing the arithmetic, she didn't do the algebra, she guessed. I think she guessed right. Marianne?
Yes.
Sub 2.
Maybe.
Ruth?
Yes.
Ruth?
Yes.
Yes. And see what you think. I'll check it up one and see. Okay, it's right here. 1, 2. 1, 2, 3, 4, 5, 6, 7, 8, 9. 2, 9. 2 and 9. How about it? Who else can guess as well as Barbara can? Anybody else can guess as well as she can? Who wants to come guess? The rule is you must not do the arithmetic, you mustn't do the algebra, you've got to come and guess. Sub 1, you want to come and guess? Thank you. How about it? Do you think he's right? What do you think? Who thinks he is right? And who thinks he's wrong? And now we will check up. And let's see. It's 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 3, 12. Three in the box. 12 in the triangle. And so it says 12 equals 9 plus 3. You're right or wrong? Okay, that really is too easy for you. How much time do we have? 10 minutes. You just have time to play a game. Do you want to play that same game or a different game?
A different game.
Take a vote. We'll take a vote. How many people want to do the same game again? Let's do the same game again. I'm interested in seeing who will win. Okay?
Same size. Yes.
The same size.
No. Yes. Yes.
Okay. We don't have too much time. Let's try it with the same sides. I'd like to see what happens this time. Okay? You don't want to do it? Who's over? Okay.
That's the losing team.
That's the losing team that wants to do that. Okay, well,
You have to give us a chance to win. Let's take over.
Okay.
Why don't we vote?
Okay, we'll take over. That's what you want to do. Now, let's see who's going to be the captains. Who was it who found the circle here that worked? Barbara, you want to be one of the captains? And let's see. Who made up the fanciest identity? Who was the first one to make up infinitely many identities?
Ruth.
Ruth, you want to be team captain? Okay. You don't have to be. You don't want to be. Okay. Who wants to be team captain? Susan, you want to be team captain? Okay, and let's let Barbara pick first. Try to pick real fast. Pick as fast as you can, will you? Won't waste time.
Really, Bob? Nancy. Lori. Anne. Ruth. Anne. Katie. No, the other one. No, the other Kate. First one got the best seat.
Now let's see, which team is on which side? I guess Barbara's team is on the outside. Barbara's team is on the outside. Susan's team is on the outside. Okay, we just lost one of our team members into the TV camera. Somehow it doesn't look to me like the two teams came out even. That's right. Maybe they did. Okay. Which team had first pick? Barbara's team had first pick, so let's let this team play first. So, Sue, tell me two numbers. Oh, we have to decide. You're the solid dot team? Right?
We won the solid dot. You have the solid dot.
Right, you'll be crosses. You'll be the solid dot. Okay? Sue. Let's try and play fast so we'll get quite a bit done.
-1, -1.
-1, -1. -1, -1. And that is a cross right there. Bob.
-1, -2.
All right. -1, -2. And that's a solid dot. Maybe.
-1, -3.
All right. -1, -3. And that's a cross. Okay.
0, 0.
0, 0. And that's a solid dot. Million.
-2, -2.
All right. -2. -2, that's a cross. And Marianne says, sorry, you people. And whose turn is it over here? Bruce, is it?
Minus 1, minus 0.
Negative 1, 0. Negative 1, 0, and that's the solid dot right there. Now let's see, whose turn is it in?
Minus 0, minus 3.
0, negative 3. Supposed to do what you say first, though. 0, negative 3. But you said 3. Hey.
0, negative 2. 0, negative 2.
0, negative 2. 0, negative 2. Solid dot there.
Plus 1, minus 2.
Positive 1, negative 2. Positive 1, negative 2, and that's a cross there. And so, you are saying a tari for them. Let's see, whose turn is it? Jones?
0, minus 1.
0, minus 1. 0, minus 1, and that's a solid dot there.
How do we get them away?
Oh, that's right. They're saying a tari to this poor fellow. Let's see, Bruce, your turn?
Minus 2, minus 1. No. I got someone there. We're going to get that guy out of here. No, minus 2, minus 1. Yeah, minus 2, minus 1. Minus 2, minus 1. They were minus 2, minus 1. They were minus 2.
Hey, it's Ruth's turn, I guess, right?
Minus 2, minus 1.
Is that what you want? Negative 2, negative 1?
Minus 2, minus 1. Told ya.
Minus 2, minus 1, and that's a cross right there, and you say 2. And now, let's see, Barbara, right? Barbara.
1, minus 1.
1, minus 1. 1, minus 1, and that's a solid dot right there. Let's see, then Kate, I guess. Well, either of you people. Ann. Who wants to take this turn, Ann or Kate? It's up to you. Ann? Okay, Sam's turn.
Plus 2, minus 1.
Plus 2, minus 1. Positive 2, negative 1, and that is a cross. All right. And now, whose turn is it? Betsy. Well, I don't care. I was going to take Betsy's turn, but Bob's turn if you'd rather, Bob. We have 2 minutes left, and then we run out of videotape. Bob, please.
1, 0.
1, 0. 1, 0, and that is a solid dot right there. Okay, now it's Kate's turn.
2, 1. 2, 1, 1. Is that somebody there too? No, there isn't. Yes, that's somebody. 1, 1.
1, 1. 1, 1, and that's a cross right there. And now Lori. You play very fast, and only a minute left.
0, 1.
0, 1. 0, 1, and that's a solid dot right there.
Let's see.
Oh, I guess, all right, 2. All right, we have only 1 minute left, and this team has the first play, so this team will play, then that team will play, and then we count up.
2, 0.
2, 0. 1, 2, 0, and that's a cross right there. And now this is the last play, and who is it? Betsy's turn, is it? Play fast so we can count up. 2, 1. 1, 2, 1, and that's a solid dot right there. And incidentally, Betsy says a tari to the cross people, but it's too late to pursue that. Counting up. Solid dots. 1, 2, 3, 4, 5, 6, 7, 8, 9 for the solid dots, and for the crosses, 1, 2, 3, 4, 5, 6, 7, 8, 9 for the crosses, and so it's a tie. And so it ought to go into extra innings, and I guess it will, but we have to get off the air at this point. All right. We'll try and finish it up, but we're not going to be on the video. Okay, but now we'll finish it up.
It's our turn.
And it's back to your turn. It's Peggy's turn.
One, two. 1, 2.
1, 2. 1, 2, and that's certainly a clever thing to do.